Alright, AP and Honors Chemistry. We're going to get into some stoichiometry problems now that require more than just a single conversion, and you will learn how to do those. So here we have a problem. How many moles of CH4 are required to form 3.2 grams of H2O? So this question involves grams and moles. So let's see how to do that. So you notice up on the top, that's our world. That's the world of grams, things we measure on a balance or on a scale. What we're trying to find is how many moles of CH4. So down in the lower left, we're going to put a question mark in that red box. So we need to get from the 3.2 to the question mark. There's only one way you're allowed to do that. You can't go diagonally, you can't go to the left and down. You have to go down and then to the left. So we need to first use the molar mass conversion for water. 1 mole of H2O equals 18.02 grams of H2O, and that will convert us into moles of water. Only when we're down in the chemical equation where we have relationships between CH4, O2, CO2, and H2O can we then move left and right, and in this case we're going to move to the left. So we're going to move over there. So this is going to be a two conversion problem. Why? Because we have to convert from grams to moles of water, and then we have to convert from moles of water to moles of CH4 where the question mark is. So there you see two boxes up above. We're going to need two conversions. So we're starting off on the left with 3.2 grams of H2O, and we're going to end up with some unknown number of moles of CH4. So our first conversion, our first equivalency is going to be the molar mass of water you see in the dark blue box on the right. So 1 mole of H2O equals 18.02 grams of H2O. So that allows us to create two conversion factors. There are 18.02 grams of H2O for every 1 mole of H2O, or equally true, there's 1 mole of H2O for every 18.02 grams of H2O. So which one of those two do you want to pick? You want to pick the one on the right. We're going to place it up in the box above. Again, understand the logic behind this. We start with 3.2 grams of H2O, but grams of H2O isn't in our final answer, so we need to get it to cancel out. So this particular conversion factor will do that. So grams of H2O cancels with grams of H2O. Again, we're not doing anything with the numbers at this point. We're just canceling units of measure. All right, now we need, and if you did that calculation, by the way, down at the bottom right, you would get 0.18 moles of H2O, but you don't do that calculation. It's an intermediate calculation, and you do not do it. Now we're ready to go from the moles of H2O across to the left to the moles of CH4 for our final answer. So the equivalency, again, just like in the last problem, is obtained straight out of the chemical equation. There's 1 mole of CH4 for every 2 moles of H2O. That's what the chemical equation is telling us. Again, we don't care about O2 and CO2 in this particular problem. Okay, so there you see the equivalency. So you can create two conversion factors. There's 2 moles of H2O for every 1 mole of CH4, or there's 1 mole of CH4 for every 2 moles of H2O. So which one are you going to choose? You're going to again choose the one on the right, because it has moles of H2O in the denominator, and you need moles of H2O to cancel out. And then there's a second reason. So there you see moles of H2O in the first conversion canceling, and in the bottom of the second conversion canceling. And so the last man standing is moles of CH4. That's the only thing that didn't cancel out, and that's what you have in your final answer. That's how you know if you set the equation up properly. You need the same thing at the top of that last conversion, moles of CH4, as you say that you were looking for in the final answer, which is moles of CH4. Now what you do is you multiply everything on the top, 3.2 times 1, and you divide by everything in the bottom. Divided by 18.02 divided by 2. And when you mash all those numbers, you get 0.089 moles of CH4. And if you're so inclined, you can go ahead and put that down in the box of moles of CH4 right above CH4, and that would be your final answer. So you see, this problem took two conversions because it needed to go from grams to moles of water, and then moles of water to moles of CH4. All right, now we're going to go how many grams of H2O can be formed from 5.2 grams of CH4. All right, well, let's take a look at this. We're starting with 5.2 grams of CH4. So we're up in the grams row. That's our world. That's the things we can measure on a scale. And we need to go to grams of H2O. That's over on the right side, also in the grams row. And that is what we're trying to find. So the question is, can we go directly from 5.2 grams of CH4 to some number of grams of H2O? And the answer is no. We don't have a relationship between CH4 and H2O up in grams. It just doesn't exist. You have to go down into the chemical equation, then to the right, and then up. So let's see that happen here. Okay, so here we go. So first we use the molar mass of CH4 to go from grams of CH4 to moles of CH4. And that'll get us in the box right above the CH4 in the lower left. Next we go across from moles of CH4 to moles of H2O, just like we did in the last two problems. Once we get to moles of H2O, we go back out, and that you use the molar mass of water. 1 mole equals 18.02 grams, and that will get you out to your final answer. So that's a 3 conversion problem. And so we're going to erase that arrow because we can't go directly grams to grams. And so here we go. You notice up at the top we're starting to set up the equation, 5.2 grams of CH4, and then we're going to end up with some number of grams of H2O. And therefore it's going to take 3 boxes, 3 conversions, because you see arrow going down, to the right, and back up. That's going to be 3 different conversions. So let's go ahead and get started. So the first one is to get us from grams of CH4 to moles of CH4. That's the molar mass relationship. Okay, that's how you related how many nails you had in grams to some number of nails. This is how much CH4 you have in grams to some number of moles of CH4. Okay, so we're going to make 2 conversion factors, 16.5 grams of CH4 for every 1 mole of CH4, or 1 mole of CH4 for every 16.5. Pause the video and think, which one do you want to use? Which of those 2? The one you want to use is this one. So you're going to put it up there. Again, be sure you understand why. Because grams of CH4 on the top, right after 5.2, cancels with grams of CH4 on the bottom. You want it to cancel because grams of CH4 does not appear in our final answer. Alright, so now we're ready. And now if you did the conversion down there on the lower left, right above CH4, you would get 0.32 moles of CH4. But you do not do this conversion. There's no need for that. We don't care about that. So now we're ready to go across to moles of H2O. So you, again, just like you did in the first 2 problems, you get the equivalency out of the chemical equation. There's 1 mole of CH4 for every 2 moles of H2O. So you create 2 conversion factors, 2 moles of H2O for every 1 mole of CH4, or 1 mole of CH4 for every 2 moles of H2O. Which one are you going to pick? You're going to pick the one on the left. Why? Because it has moles of CH4 in the denominator. That will cancel the moles of CH4 in the numerator of the first conversion. So watch the red lines. Line there, they cancel out. Okay, now you're sitting in the moles of H2O box on the lower left. And if you did this calculation, and you will not do this calculation, you would get 0.65 moles of H2O. Now we got to get from moles of H2O back up to that question mark using the molar mass of H2O. And that's going to be 1 mole of H2O equals 18.02 grams of H2O. So create 2 conversion factors, 1 and 2, 18.02 grams of H2O for every 1 mole of H2O, or 1 mole of H2O for every 18.02 grams. Which one are you going to choose? You're going to choose the one with moles of H2O on the bottom. So moles of H2O cancels and cancels. And now the last man standing, the only thing that hasn't been canceled, is grams of H2O, and that's the units we need for our final answer. So that's how we know we set the problem up correctly. All right, now we're going to multiply everything on the top. 5.2 times 1 times 2 times 18.02, and divide by everything on the bottom. Divided by 16.05, divided by 1, divided by 1, and when you do all of those numbers, you end up with 11.7 grams of H2O. And if you're so inclined, you can write that in your graphic organizer where the question mark is. That would be 11.7 grams. So that's how you do a 3-step mass stoichiometry problem. Alright, so you'll be getting a lot of practice on these as we go throughout the year. This is very central to chemistry, so you want to become good at these as quickly as possible.